You don't have to worry about this.
I'm sure you guys won't have that problem.
All right, theta equals S over R, and then S equals R times theta. I'm not sure which one we need to use at this point, but remember that's how we determine an angle. But the key thing, the angle is going to be in what? When we use those formulas? Radians. It's in radians. It cannot be in degrees. Now we're gonna have to convert here. So theta will be in radians. So we got a 14-inch radius. It rolls forward 4 feet, but we got to make sure our units match up. So 4 feet is how many inches? That's a big one there. 48. Now, when it rolls forward, okay, it's that distance is basically going to wrap around the circle. That's going to be the arc length. So as it rolls, okay, there's your arc length. This is our angle. And so our arc length will be that 48. Find that angle. So theta equals, bless you. The S, which is 48 divided by 14. But that is, bless you. That's not degrees, it's what? Radians. How do you find the degrees? What do we multiply by? 180 over 5. So take that times 180 over pi. And let's see what we got here. So times. (180) divided by pi. 196.4 degrees.
Other ways you could do this.
You can figure out how much of the circumference you have.
That's what I did.
So 48 divided by the entire circumference.
Okay.
And then times that by 360.
Yeah, that's what I did.
So that'd be the same thing. Okay. Ian,
What mode should I calculate it?
degrees. Degrees. I don't think you need to at any point have it in radians. And anything you get in degrees, if it needs to be in radians, it's easier to get the degree answer and convert it. So I would have it in degrees the whole time. Double check that. All right, read through this one. Honestly, take a second, see what you can figure out. See what you can figure out. All right, Popia, what you got? You say you got 40 meters per second?
Yeah.
Good. Excellent.
Yeah,
Excellent.
40 meters, that makes.
Centimeters. Thomas, you agree?
Yeah.
Yeah? Yeah. You're very trusting. All right, no, it should be 40 if you got that. Now, just think in terms of SR and theta, angular speed, just think of 1 second. So in 1 second, it's actually going to travel 0.8 of a radian, which would be this angle right there, 0.8. And then the radius is 50. All we really need to do is figure out how far it traveled on that arc line. That's all we really have to do. I know there's a lot of other jargon there, but that's basically what it boils down to. Well, what's the formula for SR and theta? S equals what? R times theta. If theta is in radians, is our angle in radians? Yeah. So all we have to do is, in this case here, take 50 times 0.8, and 50 times 0.8 will give me 40. That'll be the arc length. Since it travels 0.8 in 1 second, it'll travel 40 centimeters in a second, and that means we can indicate that its speed would be 40 centimeters per second on that one. Okay. So it really boils down to just an arc length problem. I know they talk about linear speed, but we just need to figure out how far it traveled in a certain amount of time. 1 second would be the easiest case here. So yes, we did some linear angular velocity. Got to know some of that, like S equals R theta, theta equals S over R for those. Tangent, theta equals 12 over 5. Theta's in quadrant 3. Find the cosecant. I'm just going to draw that out. That means that opposite is 12, adjacent is 5. We need to find the cosecant. All right, take a second. What's the cosecant in terms of opposite, adjacent, hypotenuse? Cosecant is the flip, the reciprocal sine, right? Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. We have the opposite side, but we're going to have to find the opposite, or excuse me, hypotenuse. 5 squared plus 12 squared equals, I'll call it R squared. 25 plus 144 is 169 equals R squared. Square root of that is 13. So we got a nice Pythagorean triple. All right, only thing I'll ask you, caution you on is watch your sign. You have to take into account whether it's positive or negative. And in quadrant 3, should cosecant be positive or negative? It's got to be negative. Because technically this 12 and the 5 are both negative. And so cosecant of theta is going to be negative 13 over 12. Okay, for that. Oh, good one. A little equation here. 2 cosine squared x minus 3 sine of x minus 3 equals 0. Problem is you have cosine and we got sine. And we got to fix that. It's either got to be all, for this case, either all cosines or all sines. Do you remember what we can do, I guess, in this case? Shara, you remember? Maybe.
No,
No?
they don't come to me.
Who do you think will know?
I think Dree is really good at this kind of problem. Adriana.
Oh, yeah?
Maybe convert cosine squared x to 1 minus sine squared x.
You tell her that's how you do it.
That's how you do it. That's what,
See?
Passed by softball.
Cosine squared x equals 1 minus sine squared x. So yes, we want to do that. So that becomes 2 times 1 minus sine squared x minus 3 sine of x minus 3 equals 0. Hold on, I should have parentheses there. Distribute your 2. So I get 2 minus 2 sine squared x minus 3 sine of x minus 3 equals 0. I do have a 2 and a negative 3. I'm just going to combine like terms, and I get negative 2 sine squared x minus 3 sine of x minus 1 equals 0. Where do we go from here? What do we got to do? I got sine squared, I got sine of x. You got to factor it. Now, I'm a big proponent of always having my squared term positive. It's not absolutely necessary, but to me it helps. So I'm going to move everything to the right, or basically switch all my signs. I'm going to keep it like this, but I'm going to make it 2 sine squared x plus 3 sine of x plus 1 equals 0. Okay, it's just easier for me to do that. Now we got to factor it, and just think about that. This is just no different than 2x squared plus 3x plus 1 equals 0. And my first term will be 2x. My second term will be x. They got to multiply to get that 1, remember? You only got one option. Both sides have to be positive. It's got to be a plus 1 and a plus 1. Just make sure when you FOIL it back together, it gives you the original. Now remember, instead of x, I got to go back and put in the sine of x. So that's going to be 2 sine of x plus 1 times sine of x plus 1 equals 0. And then we set each of those equal to 0. And I get sine of x equals negative 1/2. And I get sine of x equals negative 1. All right, I want to give you first shot here. This is between 0 and 2 pi. See if you remember what to do from here. Solve each of those. Sine of x equals negative 1/2. Sine of x equals negative 1. Yeah, I want final answer radians. So I mean, you can think in degrees, it's fine, but just make sure you convert your final answer to radians. See, I'm about to collect your books. I always forget. Senior.
Do you want it?
Yeah, you probably.
You're gonna make my life easier. I don't have to do
Oh, you can.
I'm sorry.
You could. Oh, that's it. You can use your calculator. This calculator works. I don't know. I checked. I got it. I'm just gonna write it down. You know, Thomas Cassidy lesson time. I'm all about this.
Give me 2 answers.
And wait a minute.
Yeah, I don't know really what to do. So I just,
Just guess.
yep.
All right. Draw it out. That's what I'm gonna do up here. Now you can, this is why we did a lot of that unit circle work. So sine of x equals negative 1/2. That means my opposite side is negative 1/2. What's going to be my reference angle? And to be negative, sine has to be quadrant 3 or 4. Thomas, what's my reference angle going to be if that's negative 1/2?
210.
Well, that's the final angle. So you even took it an extra step. Reference angle is 30, full angle is 210. That means my reference angle over here is 30, and that'll be 330. So that means we get 7 pi over 6 and 11 pi over 6. Hey, this is the calculator part, so you can, like, you know, if your brain freezes on you, just do second inverse sine of negative 0.5. Now, it's going to give you negative 30 degrees. It's not going to give you 210. It's not going to give you 330. But you convert that to 330, and you got to know your second angle. There's going to be a second angle. Sine of x equals negative 1. Inverse sine of negative 1. Negative 90. Well, most of you have this down. Negative 90 would be what? In positive angle, it would be 270. So the final answer would be 3 pi over 2. So for the sine where it's negative 1 at. So if you think about the curve, it'll be down in quadrant 3. So there's your 3 answers for that one. But you got to convert it to 1 minus sine squared factor. A lot going on with that one. Okay. Find the exact value of cosine 2 theta. If you got your identity sheet, you'll have, you can copy down the right-hand side. These are where these formulas come into play. Oh, yeah, some difference on here. Yep, don't forget there's some difference formulas, but those are on your review sheet as well. What's that? No. Slightly.
Slightly? Okay.
I was just looking over.
I didn't mess up some things, I realize now.
Oh, yeah, cosine 2 theta. If I remember right, that should be, you got 3 of them, right? The first one is cosine squared theta minus sine squared theta. If it doesn't give you a quadrant, you're in quadrant 1. Sine is 2 over 3, so opposite is 2, hypotenuse is 3. If I'm going to use this one, I need to know the cosine. What's going to be my adjacent side? Okay, do your right triangle. A squared plus b squared equals c squared. So it's going to be x squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. X squared equals 5. So you're going to get the square root of 5 there. Okay, for that one. So cosine 2 theta is going to be square root of 5 over 3 quantity squared minus sine squared, which is 2 over 3 quantity squared. I get 5 over 9 minus 4 over 9. So I end up with 1/9. Okay, 1/9. I think there's one more. All right, one more slide. And there's 3 problems on here, but they're all similar. Definitely got to be in degrees here. All right, find all solutions in the interval 0 to 360. Round your answers to their tenth of the degree. All right, sine of x equals negative 0.3. Absolutely have to use your calculator. Okay, that's not one that you can figure out in a circle. But now your calculator is going to give you one answer. I want you to think where the second answer is. Okay, so go ahead, hit sine of x equals negative 0.35. What do you get for that? Tessa, let me know what you get for, or what your calculator says. How about that?
It says negative 20.5.
All right, x is negative 20.5. That is not between 0 and 360. That cannot be one of our answers, but it will lead to one of our answers. What quadrants will this be negative in? Cleb.
What is the sign? So, 4.
4, got it.
What was the sign? -3.
3. So it's going to be positive or negative in quadrant 3 and 4. Negative 20.5 is right here. You can think of that as, I don't care if you think of it positive or negative, but we need to use that to get that angle. Take 360 minus that. And what is that, 339?
Yeah.
So 339.5. That means my reference over here is 20.5. And that means I'm going to get 180 plus 20.5, which should be 200.5. So my two angles are x equals 200.5 and 339.5 for that. All right, cosine of x equals negative 0.72. All right, so you can come up with both answers.
Can you break it? Are you sure?
And cosine will be negative. Let's see something. In quadrant 2. And quadrant 3. Ian, Kelsey, think you got it? No? You got one of them? Come on, you got one of them. Have calculator issues? All right, we'll go to Jackson. What do you got there?
136.1 and 223.9.
That sounds good. 136.1 and 223.9. All right, now hold on here. I'm not done with you. So you inverse cosine of negative 0.72. All right, that gives us 136.1. How did you find the second one? Because there's a couple ways. How did you find it?
So 180 minus that.
And that gave you what? 43.9?
Yeah.
That's your, and made that your reference angle? Then made this 43.9? I'm hoping. Okay, and then we take 180 plus that to get that second one. Anybody do it? There's another way to do it. I don't care which way you do it. Anybody just take 360 minus that? That'll also work. Okay, it doesn't matter either way. All right, last one here. All right, be careful here. Cotangent of x equals 6.25. So copy that down and think for a second. All right, you're running into a problem because you don't have an inverse cotangent, but what do we got to do? Okay, we got to write it in terms of something that's on the calculator. So I'm going to write it in terms of tangent. Don't make it 1 over. Just do this. Tangent of x, or don't make this 1 over tangent. Tangent of x is going to equal what? What do I got to do the other side? So you flip that. Make that 1 over 6.25. Now, inverse tangent. 1 divided by 6.25. Gives me 9.1 degrees. And then that's going to be quadrant 1. And then in quadrant 3, it's also positive. So take 180 plus that. So it looks like it's going to be 189.1 degrees. Okay, so 9.1 and 189.1. All right, I want to just hit a few of those from the calculator part. I mean, I'd encourage you to get through like number 16. You need to work at least to the end of the period, see how far you get. If you got questions individually, let me know. If you want to work with somebody, that's fine.
I got Jen.
Yeah, I got the question.
Yeah.
I got the
Yeah.
I
So would it be that?
didn't feel like doing the identities.
Okay.
Straight up, did not work.
Let me show you where that answer key was.
I have